Alright, this morning we're heading down the Pacific coast from Hoquiam, Washington to Newport, Oregon. Let's start by building the flight plan into the GTN. It's a simple flight plan. We're going to start with the departure airport, which is here in the fast find for us. Then I'm going to go to the Astoria VOR. And then to Newport. The Astoria VOR just adds a nice checkpoint to the route, kind of keeps us going down the coastline. I like having that in there to break up the flight plan. As I taxi out here, one habit that instrument pilots have is to do an instrument check on the taxi to make sure everything's operating the way it should be so we don't get any surprises after takeoff. And that involves, in the turns here, checking to make sure that the turn coordinator behaves properly, so we should see the turn indicating in the right direction and the ball going opposite the turn. After the turn, the heading indicator should still match the compass, which it does. It's unlikely with the HSI here that it wouldn't, but especially if you have a vacuum directional gyro, you want to double check it there. And then we want to make sure that the airspeed reads 0 or off scale. The altimeter has been set and matches field elevation. We note where vertical speed is, it's right on 0. And the attitude indicator, as we make another little turn here, should stay level. That indicates a slight nose up pitch, which is typical for this airplane. That's just how we sit on the ground. Now we're holding short of runway 24. We're just about ready to go. The pre-takeoff checklists are complete. One last thing is a takeoff briefing. I've actually added my takeoff briefing as a separate checklist right in ForeFlight, so I can't miss it. I have to get past it to get to my in-flight checklists. I have it in fill-in-the-blank style, so I can't just do it by rote and not think about it. It's got all the usual engine failure sort of first action considerations here. Those are preset decision points for things like when to go straight ahead, when to consider a turn, and in which direction. In the Bonanza, turning back to the runway is something that's just not going to happen, so I remind myself of that. But what's noteworthy here are the last two items on the list that are usually associated with IFR, but are useful for VFR too. The first one is briefing the departure procedure, and here it's really simple. It's a basic VFR departure. I'm going to depart pretty much straight out on runway 24, and then make a left turn to follow the coastline to the Astoria VOR. And we've already got the altitude bug set to 7,500, which is the altitude we're going to. But other times in this course where we're going to be borrowing from actual IFR procedure or navigating complex airspace, for example, briefing the plan is critical. What exactly are we going to do right after takeoff? The other typically IFR thing on this list is a departure alternate. The idea is knowing where you're going to go if something goes wrong shortly after takeoff. So here, it's pretty simple again. It's just we turn back and land here at Hoquiam. But it's also worth briefing some of the other airports that are close by that we could use. Because straight ahead after takeoff, there's Westport, there's Ocean Shores. They're both short runways, but if we need something in a pinch, they're right there. A little bit farther is Willapa Harbor. And then there's Astoria. If we're going to have engine trouble on this flight, there's a good chance it'll happen shortly after takeoff. And I'd like to know, especially in the event of like a partial power failure, where my nearby airport options are. Alright, so we're past the takeoff briefing checklist. I'll move on to my next checklist on ForeFlight here. And this is actually all of my in-flight checklists. The idea here is I have climb, cruise, descent, and a very abbreviated before landing checklist all on one page so that at any point in the flight I can just be one touch away from the checklist. I could be on the map here, I go straight to the checklist, and I'm at my in-flight checklist. I don't have to page to the next checklist ever. I'm right there in flight. It gives me one less excuse not to pull out the checklist in flight.
Entered runway 24, 4,900 feet remaining.
ForeFlight says we're entering runway 24. That's where we want to be. That matches the number on the runway. That number matches the HSI. And here I can sync up the heading bug. And we're off. It's a positive rate. The gear comes up. Now I'm shooting for a VUI climb here, but I don't need to pitch up and down chasing the airspeed because I know that in this plane, in these conditions, if I put the top of the cowl right about on the horizon, that'll get me really close. and then we just glance down to see where we're at for airspeed and tweak the pitch attitude as needed. IFR pilots get a little bit more precise here by flying a number of degrees on the attitude indicator, and I know a VY climb is right around 11 degrees or so in this bonanza in these conditions. At higher density altitudes or higher weights, the pitch required would be a bit lower, and you can anticipate that and pick an initial pitch attitude that gets you really close to the speed that you want. If I did pick a pitch attitude and found that I was significantly slower than expected or had a lower climb rate, the first thing I'd suspect is a configuration issue, like I forgot to raise the gear, for example. Or it could be something more serious, like reduced engine power. Now I'm going to transition to a cruise climb, which I know is about 6 degrees nose up. Bring the prop back to 2500. And that should get me around 115 knots. That'll be a trigger for a flow and a checklist. I'm going to get that as soon as time permits here. It's going to be after I turn out on course. Now I've completed my standard flow across the panel here and set things the way they should be. I have a moment where I can switch with one touch over to my checklist and verify any critical items that I might have forgotten. So gear and flaps are both up. Mixture set will lean as we go, and we'll monitor the engine gauges, which look good at the moment. And straight back to the map. Alright, we're going to level off at 7,500 here. And I'm going to just let the plane accelerate here. Leave the power set where it is. You can close the cowl flaps. You generally want to wait to set cruise power until you've reached cruise speed. That'll make this transition happen a little bit faster and reduce the higher workload time where you're just retrimming as the plane accelerates. And we're right about at our cruise speed now, so I'm going to set cruise power. It's really not much different than climb power here because we're all the way up at 7,500 feet. Throttle's going to stay full. I'll bring the prop back to about 2,300 RPM and lean the mixture for cruise. And after running our flow pattern and making sure everything is set where we want it to be for cruise, I jump back to my in-flight checklist, one touch, throttle, prop, and mixture are set, lights and switches are how I want them, and the cowl flaps are closed. And back to the map. And we're on our way. Alright, we've settled into cruise here. We've got about an hour left with nothing to do except follow the magenta line or follow the coastline here on our way to Newport. When you're IFR, precisely holding the course center line is important. It's less important usually for VFR, but there are some skills and techniques and equipment that we can use to make that a lot easier, which will lower our workload for VFR and allow us to fly with some of that same precision. There's a pretty strong right crosswind here. Right now it's 36 knots of basically direct crosswind, and often what you'll see is pilots fly a sort of curved path in crosswinds like this, as they constantly readjust the heading to point the plane where they want it to go, or they S-turn back and forth across the course that they want to be flying. But there's an easy way to quickly find the correct heading to hold the course you want using GPS track information. On the GTN 750, my track is 160 degrees. That's the actual track that I'm making over the ground, the actual direction I'm going, as opposed to my 171 degree heading. So there's about a 10 degree wind correction angle. And that 160 track matches the 160 desired track on the GPS, the direction of the magenta line. As long as those two match up, the needle's not going anywhere. On this panel, I don't even need to look at the numeric track value on the GPS though, because I have this little magenta diamond on the HSI that's indicating where my track is. So all I have to do is pick a heading that puts the diamond right on the top of that HSI course pointer, and the needle's not going to move anywhere. Then I sync up my heading bug to my current heading as a nice visual aid for holding the heading that keeps the track where I want it to be. And of course that'll change a little bit as the flight goes on and the wind changes, but just flying a heading that puts the magenta track diamond on top of the HSI pointer is going to hold us on course. Well, now I'm very slightly off course. The needle is a little bit to the left here, and the common mistake that people make is to just start turning left until the needle starts coming in, and typically you'll see pilots make much too large of a correction and end up making S-turns back and forth across the course as they overcorrect back and forth. The reason that happens is usually a lack of perspective, a lack of context. What does it mean that the needle is deflected that much. How far off course am I really? Well, with a WAAS GPS, when you're in route mode, which is indicated on the bottom of the 750 here, a full scale deflection is 2 miles. So that can give you some idea of the magnitude of this deviation here. It's not very much. And by the way, when we get within 30 miles of our destination, it'll switch to terminal mode and gets a little more precise, and full scale deflection is 1 mile. But another thing that I have up here that's helpful is on the bottom right of the GTN, I have cross-track error. Cross-track error is just my lateral distance from the course center line. So I'm 0.32 nautical miles from the center of the course, about 1/3 of a mile. So that's not very much. You can see that you wouldn't want to crank in a 45-degree intercept or something like that. As a rule, for small corrections while you're more or less on course, if you limit those to about 5 degrees or less, you won't overshoot. Incidentally, possibly not by coincidence actually, the heading bug, most heading bugs, are about 10 degrees wide, or exactly 10 degrees wide. So I knew the heading bug heading was the correct wind correction heading. If I just adjust my heading to the left side of the heading bug, that'll be enough to sort of slowly bring me back to the course center line. That's all that's necessary. And I can see if I look at the magenta track diamond, it's a little bit offset to the left. I can see the needle coming back in now, and the cross-track error slowly ticking back down to 0. There's really no need to do any larger of a correction than this. Alright, now the needle's coming back to center. I'm going to slowly bring my heading back into the bug. Verify that that's still lining up the track with my desired track. And we're good to go. We're also about 1.5 miles from the Astoria VOR, and there's a slight bend in the route there. Certainly would be hard to get lost on this flight. We've got the Pacific coastline in front of us. But in just a few seconds, there it is. We've got the GPS counting down a right turn to a 169-degree heading. There we go. I'm not going to go to a 169 heading because I still need this right wind correction in here, but it's about a 10-degree turn. We turn when it tells us to, and we'll roll out right in the center of the next course. This is obviously more useful on more significant turns than this one. But there we go. I found a heading that matches up the track with the desired track again. Recenter the heading bug. And there's no guesswork involved. This will keep us right on track. So you might be thinking, that's nice, but my GPS doesn't have, for example, cross-track error on it. And in fact, any modern GPS lets you customize pretty much any data field that's on the screen. And the default data fields may not be what you want. For example, in this plane, a lot of the information that I need is already right in front of me on the G5s. I have track and desired track, for example, on the HSI. I have wind. I have distance. On the attitude indicator, I have ground speed and true airspeed. So I don't really need those things duplicated on the GTN. So that frees me up to choose some other useful data fields there, and one of those that I've chosen is cross-track error. To customize these in the GTN, you just go to Menu and change user fields. You can tap whatever field you want to change, and you can choose from a whole array of different options. You can also choose functions. For example, we could have a CDI, a course deviation indicator here. We could have a timer, all sorts of things. Or we could have a quick link to a page. So what I have chosen are the ones that I feel like are important there. I've already explained why I like cross-track error. It gives a level of precision to navigation and gives you a good sense of how far actually you're off course beyond just a certain needle deflection. On the top left, I have estimated time en route to the next waypoint. This one's pretty critical when things get busy. In IFR or on any busy flight, you want to be briefing yourself on what's coming next and in how long that's happening. Of course, things tend to happen at waypoints or at turns in the route, so ETE to the next waypoint lets me know the next thing's happening, in this case in 31 minutes at my destination airport. I still kind of like the numeric track value up there, even though I've got the track indicator. I could change that. And in the bottom left, I've got vertical speed required, which we're going to look at in just a minute for planning descents. I also have some data fields that I can customize on ForeFlight. This strip at the bottom of the screen here, which is opened and closed with this button at the top, ForeFlight calls it the instruments. I can also put some useful things in there. So some of the things that I've chosen are, for example, the nearest nav aid. This is useful if I want to make a position report. Say, for example, I'm calling up for flight following. I know in this case that I'm 13 miles on the 170 radial, 13 miles south of Astoria. Flight time automatically starts a timer when we take off. I'm 27 minutes into the flight. I like height AGL for a sort of extra bit of terrain awareness. And then distance and ETE to destination, as opposed to the next waypoint that I have on the GTN, is useful. And climb gradient is going to be useful in assessing our performance when we're flying departure procedures, which we'll look at later in the course. Okay, we're at 7,500 feet. The airport elevation is about sea level. So to get down to pattern altitude, we need to lose 6,500 feet. We're doing 160 knots over the ground. So it's not enough to just wait until we have the airport in sight here and start descending. We've got to do a little bit of planning. The mental math on this is actually pretty simple. If we want to lose 6,500 feet, if we did that at 1,000 feet per minute, it would take us 6.5 minutes. Let's say we want to use 500 feet per minute for a more gentle descent. Double it, it's going to take 13 minutes. And of course I've got ETE to the next waypoint, which is the destination airport in the GTN here, so I can just wait till it says 13 minutes and start coming down. Realistically, I'd like to actually get to pattern altitude a minute or so before I reach the airport, so start down at 14 minutes, that'll work. Another rule, if you like, is the rule of 3, which means taking your altitude in thousands of feet that you need to lose, multiplying it by 3, and that's the number of miles early that you should start descending. That works as long as you descend on about a 3-degree slope. So at 160 knots over the ground, that would take about an 800 foot per minute descent, which is reasonable. Of course, there's a way to get the equipment to do that for you, and in the GTN, that's its VNAV functionality. On the flight plan page in the GTN, there's an altitude field that lets you set a target altitude for reaching that fix. So I can set that I want to reach pattern altitude by Newport. There's also a way that I can tell it that I want to reach pattern altitude, say, 2 miles before Newport, and that's by creating an along track waypoint. To do that, I'll tap on Newport, I'll choose a long track. It lets me specify what I want my along track offset to be, how far before or after I want to create a waypoint. I only have the option of before here because it's the last waypoint in the flight plan, but let's say 2 miles before. And there we've got a waypoint added to our flight plan, Newport -2. And now I can tell it what altitude I want to be at that point. So I tap the altitude field, and I'll say at, and pattern altitude here is 1160. Don't need to be precise, but it's actually going to put a marker on the map here too, so having that marker will be a nice reminder of what the pattern altitude is here. We'll save that. And there it is. Okay, so what has that done? Well, remember the vertical speed required that I set as one of my data fields here. Back on the main screen, vertical speed required now says negative 240 feet per minute. That means if I were to start descending right now, to hit that altitude at Newport -2, I'd have to descend at 250 feet per minute if I maintain my current ground speed. That's pretty useful in itself. GTN's done a couple other things for us too here. It's put a top of descent marker, TOD, right where it thinks we should start descending. Whether that's actually where we want it depends on how fast we want to make this descent. And so we can dig into the VNAV settings here to specify what our preference would be. So back on the flight plan again, and the shortcut to get to the flight plan, by the way, is tapping on the CDI on the GTN. We can go to Menu, and then VNAV. And we'll see that right now, the target descent rate on this leg is 875 feet per minute. And the way it's come up with that is that's just what a 3-degree angle is at our current ground speed. I can tap on any of those and change my target, either vertical speed or flight path angle, for this specific descent. Or I can set a preference that'll apply to every descent. To do that, I go to Menu, and I have a default flight path angle. And I'm just going to reduce that a little bit because I don't need to come down at nearly 900 feet per minute. And that could be pushing 1,000 feet per minute if we had a tailwind, for example. I'm going to set it to negative 2.5. And back on the map, I can prepare for that descent to begin right about where that top of descent marker is. Now, some of this is Garmin GTN specific, but the concepts here apply to most GPS navigators. Depending on your setup, you may have a more simplified version of VNav, or it might even be more sophisticated, and you might even be able to do things like couple your autopilot to the descent path. But in any case, a good working knowledge of the tech can really make your descent planning simple and efficient, which in a faster plane like this at higher altitudes is especially useful. Before we move on though, one very important caveat here is that this sort of VNav knows nothing about terrain and obstacles. Descending on the path it suggests does not assure that we're not going to hit anything on the way down. That's on you, but today, it's a clear day, there's nothing in the way. So we've got about 12 minutes to go. That's about where we said we would need to start our descent if we were going to make it at 500 feet per minute. And in fact, vertical speed required shows about 500 feet per minute right now. And we're approaching that top of descent point.
Vertical track.
All right, there's vertical track on the GTN. That means we're going to start coming down in about 1 minute. So I'm going to actually start coming down now. And I'm just going to try to match my vertical speed with what the vertical speed required says. A vertical speed required is calculated using our current ground speed and how much altitude we have to lose. So if I accelerate, the vertical speed required is going to increase. Let's also set the altitude pre-select down to 1200 for pattern altitude. Really should do that before starting the descent, so you always have a bottom to the descent when you start. And ground speed will just change as we descend. The winds are going to change as we descend. We might accelerate in the descent a little bit. So it's really a continuous process of adjusting vertical speed to match what vertical speed required is. But having the GPS telling me when to start descending and having that agree with what my mental math said it should be is pretty useful here. I don't necessarily do the mental math on every descent, but getting in the practice of doing it occasionally provides a nice sanity check on what the GPS tells you. You kind of develop an instinct for when the descent should start, because it's really easy to program the GPS wrong for this. And if it tells you to descend 10 miles earlier than it should, you're probably going to notice that if you're in the habit of thinking about these things in general. Okay, as I enter the 45 for the downwind here, I'm going to talk about a few standard procedures that I have that help prevent something like a gear up landing and also help me to fly the airplane more precisely in the pattern. The first one is just always using discrete power settings and configurations and having an expectation of what sort of performance is going to result. So I've got 16 inches of manifold pressure. I'm extending approach flaps here, and I know this should slow me to 90 knots. The gear is still up. It'll take a little while for that to happen. And then I'll always use the gear to start the descent on the downwind. Power's right about at the bottom of the green arc on the manifold pressure. And I should really never have to bring the power below the green arc before the gear is down. So that would be a warning to me that I've forgotten the gear. I'm never just making arbitrary power changes here. I'm always thinking in terms of discrete numbers. So we're entering the downwind. All right, we're abeam our touchdown point, so let's put the gear down. I'm going to keep my hand on the gear handle and wait for it to do its thing. I've got 3 green lights down and locked. I can feel the performance change. The plane wants to descend. It'll maintain about this 90 knot airspeed. All right, now we'll turn base. Every turn in the pattern is an opportunity for me to verify that the gear is down. There's 3 green lights. Performance is still what I expect. We have stabilized at about 90 knots here. And now as I turn final, I'm going to put in the last notch of flaps. And I know that that should slow me to 75 knots. It takes off about 15 knots of airspeed.
500.
That 500 call out that you just heard on the GPS, or on ForeFlight rather, is another prompt for me to verify gear down. So 500, gear down. If it wasn't, I go around. Don't try and solve the problem on short final. Go around, regroup, do it again. Clear these trees, which are really a bit higher than they should be. A little bit of crosswind input. Throttle back to idle. Gear is down. There we go. All right, and welcome to Newport.